Welcome to Your Math Explained, where we make math simple and clear. My name is Angela, and in this video, we're going to take a look at a couple more problems involving solving exponential equations. So in the last video, we tackled basic exponential equations by using the same base. Today, we're taking things up a level with 3 intermediate examples. No logarithms needed, just algebra and some smart thinking. So let's get into it. Our first problem, we're asked to solve 4 to the power of x is equal to 8 root 2. So we're going to do what we did in the previous video, which is to rewrite everything in the same base. So on the left-hand side, 4 can be rewritten as 2 to the power of 2. So we're going to write this as 2 to the power of 2 to the power of x. 8 can be written as 2 to the power of 3. And then root 2 is just 2 to the power of 1/2. Now we're going to apply our exponent laws and combine our exponents. So on the left-hand side, this is going to be 2 to the power of 2x. And then the right-hand side, that's going to be 2 to the power of 7 over 2. And now we have the same base again, which means we can just go ahead and compare the exponents. So we end up with 2x is equal to 7 over 2. And then solving for x will give us x is equal to 7 over 4. Okay, moving on to the next problem. This one's a little bit more complicated. So we have multiple terms with an exponent. So the trick here is we're going to actually do a substitution. So we're going to let a be equal to 3 to the power of x. So now we can see that 3 to the power of 2x, that is just a squared. And then we have 10 times 3 to the power of x, which means this is 10a, plus 9 is equal to 0. And now this is just a quadratic equation, and we can solve it by factoring the left-hand side. And once we do that, we get a minus 9 times a minus 1 is equal to 0, which means we have a is equal to 9 or a is equal to 1. But remember, we did the substitution ourselves. A is equal to 3 to the power of x. So we need to substitute that back into a. So therefore, we're going to get 3 to the power of x is equal to 9, or 3 to the power of x is equal to 1. And we can solve this by inspection. So 3 to the power of 2 is equal to 9, which means x is equal to 2. And then 3 to the power of x is equal to 1 tells us that x here is equal to 0. So those would be the 2 solutions to this problem here. And now we come to the last example of this video. So this one requires a little bit more thinking. We're not just asked to solve this equation here. We're asked to find for what values of k will this equation have no solution. So the first thing we're going to do is we're going to, again, set both sides so that they have the same base. So that means the left-hand side, 4 is going to be rewritten as 2 to the power of 2. And then we still have our exponent, which is x squared minus x. And then the right-hand side, we're going to rewrite 8 as 2 to the power of 3. And again, our exponent stays, so that would be 2x plus k. Okay, now we're going to use our exponent law to multiply the exponents. So meaning the left-hand side is going to be 2 to the power of, this will be 2x squared minus 2x. And then the right-hand side is going to be 2 to the power of 6x plus 3k. So now we have the same base on both sides. We can go ahead and equate the exponents. And we get 2x squared minus 2x is equal to 6x plus 3k. So we want to solve this, and we want to find for what values of k will this have no solution. So here, this almost looks like a quadratic equation. So let's go ahead and move everything over to one side and set the other side equal to 0. So we get 2x squared minus 8x minus 3k is equal to 0. So now recall, in order for this to have no solution, we need the discriminant to be equal to a negative number. And the discriminant is the part that is under the square root in your quadratic formula. So let's go ahead and write that down first. So the discriminant is denoted by this triangle is equal to b squared minus 4ac, where a, b, c are the coefficients of your quadratic equation. So here we have a is equal to 2, b is equal to -8, and c is equal to -3k. So let's go ahead and plug those numbers in. So we have our discriminant is equal to -8 squared minus 4 times 2 times -3k. And in order for this to have no solution, we need this to be less than 0. Okay, so then we get 64 plus 24k is less than 0. So that gives us k is less than -8/3. So that tells us if k is less than -8/3, then our discriminant is going to be less than 0, which means this quadratic equation here will have no solution. But we got here by simplifying our original equation and getting both sides the same base. So we have arrived at the solution that if k is less than -8/3, then our original equation is going to have no solution. So a quick recap of everything we covered in this video. In the first example, we rewrote all terms with a common base and used exponent rules to solve for our unknown. In the second example, we added a clever substitution so that the equation looks simpler, and then solved for our unknown. And then in the last example, we linked an exponential equation to a quadratic, and this time we used the discriminant to decide when there is no real solution. So now it is your turn to give this a try. Can you solve this exponential equation here? And make sure to leave your answer in the comments below and let us know if you'd like to see more content on solving exponential equations in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.